Hi class, we are now on chapter 7.8. This is acid, base, and gas evolution reactions. So gas formation are double displacement reactions. They are switching dance partners. So the cation will go with the anion of the other compound, and the anion will go with the cation of the other compound. So basically just switching dance partners. A reaction that produces a gas from reactants not in the gaseous state. So it is a product of two compounds that are not in the gaseous state. They are in aqueous solutions. So many gas formations involve two steps. This is a little difficult, so make sure that you take notes if you need to, because this could be a little confusing. We form, when you are balancing and switching partners, what you will notice is that you might make one of these as a product. This is the unstable intermediate product. It will not stay. What it ends up producing, it decomposes, and this is the final product, is the water. If you have carbonic acid, you end up with water and CO2 gas. If you have sulfurous acid, you end up with water and SO2. And if you end up with ammonium hydroxide, you end up with water and ammonia. So this is a good thing to take notes on, because these are things that people tend to forget. Acid-base reactions are reactions that form water upon mixing an acid and a base together. So if you see here an acid-base, this is a neutralization reaction is what it's called, because they are both neutralized out. What the products are at the end are water and the salt that's left over, the anion and cation from the base and the acid. So in this case, you see there is no base, there is no acid left, it's just water. So this is a neutralization reaction, an acid and a base. Generally forms a water, an ionic compound, which is just the remainder leftover ions. The net ionic equation for this would be the proton or hydrogen ion and the hydroxide ion, which produces the water. So we would kick out the spectator ion here, spectator ion here, and that would leave us with just the net ionic equation of a neutralization reaction. So here is the chart in your section, and it is showing the acid, and it shows the formula. So hydrochloric acid, HCl, hydrobromic acid, HBr, nitric acid, sulfuric acid, perchloric acid, acetic acid, and then the bases as well. So these are the common acids and bases that you definitely should know. So gas evolution reactions. Some aqueous reactions form a gas as a product. So it could be oxygen, it could be hydrogen. These reactions are called gas evolution reactions. So they are not they come from, if you look here, aqueous solutions, but somehow we end up generating a gas as a product. Aqueous in a solution. Is that right? Compounds that are in aqueous solution. Let's just leave it at that. So here we have an acid and we have lithium sulfide, but this ends up producing a gas with lithium sulfate as another aqueous. So there's a gas here. This is a gas evolution reaction. Another gas evolution reaction forms an intermediate again. So here we have another intermediate, which is what should look familiar from what I posted here. That's what you can see. Here's a gas, and a gas. So these intermediates that are not stable will end up producing this as the final product. So when you write this out, this is what should be at the end of the products, not this. So if we look here, another gas, so what we do is, this is where I'm saying you might get confused. If you switch these ions out, switch partners, what you will notice is that you'll come up with this as a product. And it's not a stable product. So this is one of those things you just have to know, that this is going to change into these products here. So you're going to have sodium chloride, but you're going to end up having water and CO2. This is a gas evolution reaction. You have an intermediate that changes into this. And it's just one of those fun things you should know. So in this case, we start out with, as you can see, if you switch these ions, you end up with compound. Again, not stable, and it produces water and CO2. So you break this up into this. This would be the final equation of a gas evolution reaction, not the carbonic acid and sodium nitrate. Then you balance it out. So you may get this, and if you get this, that's your indicator that something's not right. You have to break it up, and then you balance it out as a normal equation. Again, this is just more examples of the same thing. Here's carbonic acid, this would not, this is not an acceptable equation. You have to break it up. That's these fun things you have to know. Break it up into the final, and here is the final complete molecular equation. All right, and here's a list. I took this from another book so you can see if you have, this is an intermediate. I put this on the other page. This is what you're going to have. This is on the this is on the product side. This is what's being produced from this reaction. And then again, I'm giving you more examples of breaking these down. Notice we're not showing the intermediate, we're just showing the final products. So if you wanted to look, you'd have to look back here to see that. But the final products are a water, a gas, and a salt. 3 products. Write a molecular and net ionic equation for the reaction between aqueous nitric acid and aqueous calcium hydroxide. So recognize this is an acid and a base reaction. So if you have an acid and a base reaction, this is a neutralization reaction. Our net ionic equation should be water that is being produced. Okay, so here we write it out from the information you have here, aqueous, aqueous. So we didn't put this, I should have put it on here, but we have it. This is, let's just say, our skeleton for the moment. Then and I still didn't put it, shame on me. Add the physical states. See, I meant to do that. So now we're going to add the physical states. So you just pull everything out, then put the physical states, and they're listed above. So that makes this really easy. So we have aqueous, aqueous. Water is always a liquid. It's considered pure substance, so it's a liquid. And then we have aqueous, if you're dealing with just plain H2O. So, so as you can see here, we have water as a liquid, and then we have the remainder of the ions that did not participate in the neutralization reaction. Now we get to balance it. So we have to look and make sure it's completely balanced through, and when it is, you have a completed molecular equation. But we want the net ionic equation. So the easiest way is, since you know this is a neutralization reaction, you don't even have to go through the total ionic equation unless it specifically asks for it. But because this is a neutralization reaction, the product is always water, and in order to have water, you have hydroxide and you have hydrogen. However, the difference here, you still have to balance it out. Since there would be 2 here, you have to make sure you have the 2. But this could also be reduced down. Since there's 2's, we don't deal, I should have reduced this down. This 2's all could have been divided out, and it would just be left with 1 hydronium ion, 1 hydroxide ion, and 1 water molecule. Okay, so write a molecular equation for the gas evolution reaction that occurs when you mix aqueous nitric acid and aqueous sodium carbonate. So this has a carbonate, a sodium carbonate, and this is an aqueous. So this should kind of alert you right here, this carbonate, that this is a gas evolution reaction. This means that you should expect a gas as a product. So let's write this out. And you have it here, aqueous, aqueous. Now, if you switch partners, you'll end up with this. This should alert you that there's something that isn't right because this is intermediate. So you should know that this breaks down to this. And this here would be the final products of this reaction. So then we have to balance it out. So you write, we pull everything together. That would be the actual reaction and dismiss the intermediate and balance it out. And that is it.